Hi. The main objective of this ICP7 is to extract the data from the website, Wikipedia, Google, using the web scraping method in Python by Beautiful Soap API, using the Beautiful Soap API. And the next one is implement the basic NLP tasks, which are tokenization, POS stemming, and lemming, and name entity recognition and engrams, and also implement the TF-IDF and Navy base machine learning algorithms on the news group. Yeah, let's see the demo part of it. So the first cell over here describes about the web scraping methodology which I've used, that is Beautiful Soap. So here I'm downloading the Google Wikidata. So if I run this cell, I would be getting the data in the I'm writing this content in the Google text. So I'm only getting the text which is under the div class, the class for the MW parser output. So I'm storing entire data in the Google text. So once it's done, I'm performing the basic NLP tasks on this data set, on this text file. So these are the first method over here. What I used is just the tokenizer. So there are two things which I've used. One is word tokenization and sentence tokenization. So sentence tokenization is like it would be split. Would create at the particular part of a sentence, whereas word tokenization, it would split for the each word. So that is at sentence level and this is at word level. If you see, this is at sentence level and this is at word level, old tokens and S tokens. The next method which I've used is stemming. So I've used three stemming over here: Porter stemmer, Lancaster stemmer, and Snowball stemmer. So each has its own functionality. So to see that, I've taken the first 7 words and I performed stemming on each of them. The first one is just normal Porter stemmer, the next one is Lancaster stemmer, the next one is Snowball stemmer. This is how it looks like. If using the Porter stemmer, it is this article, C article. So each has its substring part, each has its own thing. So company. And the next which I've used is lemmatization. I've imported the WordNet lemmatizer, and here as well I've performed on the first 6 words of a sentence. So this is how it looks like. The basic difference between lemming and stemming is they do the same standardizing, but whereas in lemming it sees the WordNet library, WordNet digital library, and it has the meaning to the word which it downgrade, which it creates a new word, whereas stemming it doesn't do that. And the next method which I've used is engram method. So here I've taken 2 engrams. One is bigram and trigram. The bigram is it takes the first 2 words, it takes combination of 2 words, whereas trigram it takes the combination of 3 words. So in this bigram, if you see, this is the basic text. Basically the text is the article is about the company. So in the bigram it takes 2 by 2 each. So this article is this is about, whereas in diagram it would consider the first 3 words and the next 3 and continuously. And the next is what I've used is POS tagging and named entity recognition. So here I've taken the first 2 sentences and I performed POS and enchant. We can see that the article in the each of it tells what is it about. It is noun and verb or pronoun and so on. Yeah, the third part is implementing the TF-IDF on this Google data, on this data set called fetch news group, and on this exported, on the TF-IDF data, running KNN and implementing KNN and Navy base on that. Let's see. So there are basically 3 levels. On the first level, just TF-IDF without any arguments. So this is how it is. So the same thing goes here as well, importing the necessary libraries in the TDF, initializing it and fitting and transferring on the train data. So here we see that this is nothing but the number of rows versus columns. So each word it is split into a column. To see the same, I have on the vector data I performed get feature names. Here are the distinct column names which are present in this TF-IDF. So now I'm trying to see the transformed data. So here it shows if the data is present in that particular column, it is represented to n value, whereas if it is not present, it is designated with 0. So the same thing I have converted into pandas to visualize the same. So this is how it will be. This is the columns and the data under that column. So as it is, I'm just printing the head part, the first 5 rows of it. On this data, I'm giving this input to the models. The first model which I gave over here is Naybase, and other one is KNN. So here we are passing this TF-IDF transformed data as an input, and we are predicting, and we are fitting with that and building the model and testing it, predicting on the unseen data. The unseen data over here is we are just transforming. We are not fitting with the TF-IDF. If we fit with the TF-IDF, we are it won't be an unseen data. So here we are transforming. We are just performing the transform function. So on the Naybase we got accuracy of around 77%, whereas with KNN it is 64%. So now let's see at the second level. In the second level, same with TF-IDF, we are passing an argument called n-gram range, where we are giving and where we are passing 1, 2 as the n-gram. So it sees the binomial and normal range, normal column value. So after fitting, I see that these are the number of rows and columns. And to see the number, to see the distinct column, to see the column names, here it is. So one combination of 1 and combination of 2, everything at upwards. Whereas on the transform data to verify the transformed data, the train fit transform data, this is it is. So this is the column name and the data under for each column. On this data, we are building 2 models. One is Naybase and other one is KNN. On the Naybase, we are using this data as the input and predicting on the unseen data. Here as well, the prediction of the data is based on the just transform data. We are not fitting it. So for the second level, Naybase is accuracy is 76%, whereas KNN is 59%. Now let's see the third level. So in the third level, we are passing n-gram along with the stopwords as English. So here as well, we are fitting and transforming the data. So these are the distinct columns present under that TF-IDF, and this is the data. And we are building 2 models on this TF-IDF transform data. On this as well, we are doing on the test data, which is just transformed, which we didn't fit. On this data, there are 2 models which we build. One is Naybase and other one is KNN. The same thing goes here. The Naybase it is 80%, whereas KNN it is 64%. Yeah, this is all about ICP7. Thanks.